Hello audience. Engineers can simulate infinite and finite phased array antennas with all electromagnetic effects, including mutual coupling, array lattice definition, finite array edge effects, dummy elements, element blanking and more, through advanced unit cell simulation. A candidate array design can examine input impedances of all elements under any beam scan condition. Phased array antennas can be optimized for performance at the element, subarray or complete array level based on element match, passive or driven, far field and near field pattern behavior over any scan condition of interest. We will perform the E-field simulations to find out the antenna characteristics on the phased array unit cell radiated energy at 4.5 GHz frequency range. In the simulation window you can see, phased array unit cell antenna model. First, we verified this model for boundaries conditions and excitation levels. Define mesh operations on model for excitation. Decide radiation sweeps and frequency levels. Now we will analyze the antenna characteristics driven by the simulation. Gain of an antenna. In electromagnetics, an antenna's power gain or simply gain is a key performance number which combines the antenna's directivity and electrical efficiency. In a transmitting antenna, the gain describes how well the antenna converts input power into radio waves headed in a specified direction. Near field. When a signal from a transmitter is applied to an antenna, it sends out electromagnetic waves into free space. The in-field characteristics vary as a function of distance from the antenna. They are broadly divided into two regions, the near-field region, and the far-field region. The near-field region is the region right next to the antenna. Reactive near-field. In this region, the E-field and H-field are 90 degrees out of phase with each other and are therefore reactive. Radiative near-field. This is the region where the M fields start to transition from reactive to radiating fields. Directivity. The directivity of an antenna is a measure of how much it concentrates power in a given direction, assuming the antenna is 100% efficient. The directivity of the antenna is always taken with respect to a known antenna, which is usually an isotropic radiator. Radiated power. EIRP is effective isotropic radiated power, also called the equivalent isotropic radiated power. In antenna measurements, the measured radiated power in a single direction, that is, for a fixed theta and phi, is known as the EIRP. Near-field polarization. Polarization of the antenna is the polarization of the wave radiated by the antenna in the E-field. If the vector rotates counterclockwise, clockwise, then the antenna polarization is RHCP. If the polarization is RHCP, the cross polarization is LHCP. The last important quantity to consider is an antenna has input impedance, since an RF system, with its own impedance, needs to eventually interface to the antenna. It would not be any good if the antenna could not be impedance matched to the rest of the system, since an impedance mismatch it would produce reflection and hence result in inefficient power transfer to or from the antenna.